Okay, so the next power rule is for the power of a power rule. This means you have a power and you have another exponent. Okay, so you can see here that you've got x to the exponent a, evaluate that, and then put it to the exponent b. And that's supposed to be x to the ab. So you multiply those two exponents. So now we're going to see y here. Get it shown here. Okay. So if you had something like x to the exponent 2, all to the exponent 3. Well, let's look at this exponent 3 first. Exponent 3 means write what's inside out 3 times. So x squared times x squared times x squared. Okay? Now you can expand it one more time. You have 3x squareds. So now you're going to write out the x squareds. Okay? So you've got x times x times x times x times x times x. So really what you have here is 3 groups of 2. When we think of that wording, that means multiply. 3 groups of 2 means multiply. So that equals x to the 6, which is x to the 3 times 2. Okay? So 3 times 2 means 3 groups of 2. This is x to the 6. If you did it in general here, okay, you've got x to the a to the exponent b equals x to the a b times. Okay? So for each of these a times, you've got b of them. So you've got b groups of a. So it's x to the ba. And that's where we get that nice formula. So some examples here. Well, 3 to the 7 to the 3 means just multiply those. And it equals 3 to the 21. Okay, you could evaluate that, but this is as far as I want you to go at this point. Okay, so that's 3 to the 21. 3 multiplied by itself 21 times. Negative 5 to the 3 to the 4. Well, you're just going to multiply these exponents, leave the negative 5 alone. Okay, so it's negative 5 to the 12. X to the 5 to the 11 is x to the 5 times 11, which is x to the 55. Just applying the rule. And now, here's a power of a power of a power. So, on the middle two, you're going to go y to the 3 times 2. And that's going to give you a number. And then you're going to do that to the 5, which means 5 times that. So really, if you keep nesting them like this, you're just multiplying all the exponents. Okay, and that equals y to the 30. 5 times 2 times 3 is 30. The next power rule is power of a product. Okay, so that's 204. And here is the rule for it. xy, all to the power exponent a, equals x to the a, y to the a. So let's write this out. It's actually pretty simple. So xy to the 3 equals xy times xy times xy. 3 of these xy's. And in multiplication, you can distribute them around in whatever order you want. Okay, so let's put multiplying between any of them. And you can reorder them. You can bring all the x's to the front and y's to the back. And then you have x to the 3, y to the 3. Okay? Do the same thing for any variable a, or any exponent a. So xy to the a is xy written out a times. And then you can resort it and bring all the x's to the beginning and all the y's to the end. And you're still going to have a of them, of each of them. So it's x to the a, y to the a. And you end up with this as your solution, okay, which is the rule. So let's look at some examples for that one. And we've got here 3x to the exponent 2 means 3 to the 2, x to the 2. 3 to the 2, if you evaluate it, 3 to the 2 is 9. 3 times 3. So you get 9x squared. Okay? X to the 7, y to the 7. You can distribute that 7 in. It becomes x to the 7. Sorry, xy to the 7 becomes x to the 7, y to the 7. 3. This is one that people keep forgetting sometimes, is to bring this exponent into everything. So it becomes 4 to the 2 and x cubed to the 2. Okay? So now you're using tool 3, which is the power of a power rule. So 4 to the 2 is 16, 4 times 4. X to the 3 to the 2, well, 3 times 2 is 6, so it's x to the 6. And then you have x to the 3, y to the 5, all to the exponent 3. Well, you distribute this exponent in, you become x cubed to the exponent 3, y to the 5th to the exponent 3. You bring it into each piece. Now you have the power of the power rule. 3 times 3 is 9. 5 times 3 is 15. Okay. Now we look at power of a quotient. So x over y to the a, this works very similar to the other one, equals x to the a over y to the a, because of the rule for multiplying fractions. Okay, so here let's take a look at it. X over y all to the exponent 3 means x over y multiplied by itself 3 times. Okay. Multiplying fractions means multiply the top times top, bottom times bottom. So we can bring this all into 1. And the top just ends up being x to the 3, bottom is y to the 3. So we're able to distribute the exponent in from a power of a fraction to 2 powers. Okay? And here it is in general, just using a times instead of 3 times. Same reasoning. Okay, some examples. Example 1 here, 2 over 3 squared equals 2 squared over 3 squared. You can evaluate those and you get 4 over 9. Okay. X over 5, exponent 3, is x to the 3 over 5 to the 3, which is x to the 3 over 125 if you evaluate 5 to the 3. Okay. And 2x over y all to the 3 means 2x to the 3 over y to the 3, and now you have to distribute the 3 in, as in the previous tool. Okay, and so it's 2 to the 3 x to the 3 over y to the 3, and 2 to the 3 is 8, so we end up with this as the nice answer. Similarly for this one, you got to distribute in, so distribute into the top and the bottom, and now we have to do the other rules as well. So 3 squared, x squared squared from here to here. This you multiply it 2 and you get y to the 6. 3 squared is 9. X squared squared is x to the 4. 2 times 2 is 4. Okay, so that's that one. 0 exponent. This one's kind of neat. Okay. So if x doesn't equal 0, anything to the 0, x to the 0, is 1. And there's a nice reason for this. We agree that 3 over 3 equals 1. Right? 3 divided by 3 is 1. Also, 3 divided by 3 is 3 to the 1 over 3 to the 1. If we use the division law, tool 2, you subtract the exponents. So that equals 3 to the 1 minus 1. 1 minus 1 is 0. So 3 over 3 equals 1, but 3 over 3 using the exponent laws also equals 3 to the 0. So that means that 3 to the 0 is 1. Okay? This is true for any exponent. So 1 equals x to the n over x to the n. That's a number divided by itself, so it's got to equal 1. If you apply the power rule to this, you're going to subtract the exponents, which gives you 0. So x to the 0, anything to the 0, equals 1. Okay. Examples, 2 to the 0 equals 1. Negative 5 to the 0 equals 1. Okay. Negative exponents. So x to the negative a equals 1 over x to the a. Okay. This is based on how we've defined everything else. This is just how it works out. Okay. 1 over 3 to the 4 equals 3 to the 0 over 3 to the 4. Remember, anything to the 0 equals 1. Okay? So I'm transforming 1 into 3 to the 0. So I have the same basis, and I can apply the quotient rule. Now what do you do with this? You subtract exponents. Okay? So 0 minus 4. 0 minus 4 is negative 4. 3 to the negative 4. So 1 over 3 to the 4, if you look at this, becomes 3 to the negative 4. And that's what our rule is looking at. So anything with a negative exponent doesn't make it a negative number, just turns it into a fraction. Okay? So that means 1 over x to the a equals x to the 0 over x to the a, because 1 equals anything to the 0. And that equals x to the 0 minus a, which equals x to the negative a here. And that is the rule that we're looking at. Okay? Some examples. 3 to the negative 1. Well, that equals 1 over 3 to the 1, which just equals 1 over 3. 5 to the negative 3. That equals 1 over 5 to the 3, which equals 1 over 125. Okay? And that's it for the exponent laws. Actually, let's do some more here. A couple more. So 3 to the 2 to the negative 3 equals 3 to the negative 6, because you multiply the exponents, and you end up with 1 over 3 to the 6. 4 over 7 to the negative 1. Well, you can do what you do here is you do 1 over that, right, to the 1. Well, when you're dividing fractions, you invert and multiply the second one. So it's 1 times 7 over 4, which is 7 over 4. So anything to the negative 1, if it's a fraction, you're just flipping it. It's called the reciprocal. Okay. 3 over 5 to the negative 3 is 5 over 3 to the 3. You flip the fraction, make it positive. Okay. And then it's 5 to the 3 over 3 to the 3, which gives me 125 over 27. And this one over here, well, we've got 3x squared over y to the 3 to the negative 2. Distribute that in. Actually, flip it first. So flip the whole thing to get rid of the negative, and then you distribute it in. So it's y cubed squared over 3x squared squared. Okay. And then you multiply those to get 6. Distribute the 2 in, get 3 squared x squared squared. And y to the 6 over 9x to the 4th is the final answer. Okay. And that's it for exponent laws.